So on the picture, mark a pair of corresponding angles. So I might say this angle and this angle are corresponding. Consecutive interior, that'd be this one and this one. Alternate interior, that'd be this one and this one. Vertical, those are x angles. And alternate exterior, I could say this one and this one. So I'll let you do that one yourself. It's just like the problem from before. Number 8, it's not asking us to solve anything. It's just saying what can be concluded from the picture. There's quite a bit going on here. And you might have more than one thing to say. But one thing I do see is that this angle right here, angle B, is 90 degrees. I could also call that angle CBA. I could call that angle ABC. There's many different ways to name this angle. Okay. I also could see, based off this symbol, that shows congruency. So now I could say that CB, and I have to remind myself, is that a ray? Is it a line? Is it a segment? Because it doesn't go off forever, it's a segment. So CB is congruent to BA, or you can put AB, same thing. So that's mathematical notation, or I could say CB, the segment CB is equal to the segment BA, or I should say congruent. Okay, if they asked about the ray, this is ray BD. It's a ray because it starts off here, goes in one direction. But other than that, I don't see anything else that I could conclude from this picture. Okay, problem number 9. They want me to prove that 1 is congruent to 2. Now, this is called angle hopping, so it's up to you how you want to hop. You cannot just jump from 1 to 2. It's too far away. And then one thing that they have to tell you, or you cannot angle hop, they have to tell you that things are parallel. So let's just assume that this line is parallel to this line, is parallel to this line. Let's also assume this line is parallel to that line. If they don't tell you that, then technically you can't move anywhere. You have to know that they're parallel to say that they're congruent. So we're going to start at 1, and we could angle hop to this one, and then this one, and then this one, or maybe I go all the way down, and then over, and over. Or maybe I decide to go this way, that way, that way, that way, that way, that way. So there's many different responses you could write down. So whatever I'm about to put is probably the short method, because that's kind of how I am. So let's first go to 1 to 20. So I'm going to say that angle 1 is congruent to angle 20. And then proof means why. Why do I know those are congruent? By the corresponding angles postulate. So now I'm at 20. And then I am going to go 20 to 16. And again, there's multiple paths here. And I'm going to say that 20 is congruent to 16. How do I know that? Well, by the corresponding angles postulate. I like to use the corresponding angles postulate as much as I can. It's the one that's easiest for me to memorize. And then, if I wanted to, I could do alternate interior or congruent. but I want to stay on the right, so it doesn't make any sense to do anything but corresponding again. Now I'm going to jump from here to here, and I'm going to say 16 and 13 are congruent. Why? Well, you'll never guess corresponding angles. They're in the same spot. And by the corresponding angles postulate, if a transversal intersects two parallel lines, then the corresponding angles are congruent. So I went 1 to 20, 20 to 16, 16 to 13. Now I need to go 13 to 2. So 13 to 2. And 13 and 2 are also corresponding. So I'd say angle 13 is congruent to angle 2. Why? Because they're corresponding angles. So I want 1 is equal to 20, but 20 is equal to 16, but 16 is equal to 13, but 13 is equal to 2. I want to say that 1 is equal to 2. Well, if 1 is equal to 20 and 20 is equal to 16, then 1 equals 16. But 16 equals 13, so 1 equals 13. But 13 equals 12, so 1 is equal to angle 2. I meant to say 2, not 12. So if those are equal, if 1 equals 20, then 1 is 16. If 1 is 16, then I could use the transitive property multiple times. So I could jump 1, 20, 20, 16, 16, 3, 13, 2. That means that 1 is congruent to 20. And the property says if A equals B and B equals C, then A equals C. That's called the transitive property. You may see this word trans. We just went over that last chapter, translate, move. So we use transitive property multiple times. I mean, if they're all equal, then of course 1 is equal to 2. So that is the transitive property, and I just proved, I don't know where 20 came from, I'm sorry. I just proved that angle 1 is congruent to angle 2, and notice that's what they wanted me to prove. Alright, so we're supposed to prove the following. And all they tell us is that line A and B intersect at a point. And they want me to prove that the measure of angle 1 is equal to the measure of angle 2. Now you might be saying, wait a minute, 1 and 2 are vertical angles. And by the vertical angles theorem, if two angles are vertical, then they have equal measures, so 1 equals 2. That would be the short proof. Unfortunately, they want us to prove the vertical angles theorem. So we're going to prove it. So we can't just jump straight from 1 to 2. So we're going to do a different path. We're going to go 1 to 3, and then somehow make it 3 to 2, and then say that 1 and 2 are the same. So your first step when you're doing a proof is to write out the given. And all they told us was one given. Line A and B intersect at a point. So we'll call that step number 1. We'll make sure we see that they're all even. So that's the first thing we know. They intersect at a point. Next, and again, it's just like writing an essay. You can make these things as long as you want. But I'm going to say that there's a relationship between 1 and 3. And I'm going to say angle 1 and angle 3 are linear pairs. And I'm also going to say that 3 and 2, I almost need more room, so I'm going to write it over here. Angle 3 and angle 2 are also linear pairs. And how do I know that? That's the definition of linear pairs. So that's step 2. Okay. So what do we know about linear pairs? Well, if they're linear pairs, we also know that they're supplementary. So, and you really don't need both these steps, but now I'll say angle 1 and 3 are supplementary. I could also say that angle 3 and angle 2 are supplementary. How do I know that? Well, linear pairs are supplementary. Really, we don't really need this step 2 because, I mean, we could have just said they were supplementary and just skipped that step. Next, we're going to try to write this as an algebraic equation. So my algebraic equation, I'm going to say that angle 1 plus angle 3 is equal to 180. And I'm also going to say that angle 3 plus angle 2 equals 180. How do I know that? That's the definition of supplementary angles. Alright, so I have pretty much a really, really long proof. It's almost like I'm trying to write this out as long as I can. But if I was writing this proof, I would probably just start off here and then jump to that they were supplementary. I probably wouldn't have step 2 and 3. Okay. So I'm showing you how long a proof can be. This is like a very... Next step, if they both equal 180, then I can set them equal to each other. I can say that angle 1 plus angle 3 is equal to angle 3 plus angle 2. And this, I mean, if they're both equal to 180, so then they're equal to each other, that's called the substitution property. And then finally, using that, if I subtract 3 from both sides, then I get just 1 equals 2. So then 6, angle 1, is equal to angle 2. If I subtract 3 from both sides, we call that the subtraction property. Okay, and so I just proved through quite a few steps that angle 1 is indeed equal to angle 2, and we are